Now we will talk about our empirical rule, or the 68, 95, 99.7 rule. This rule only applies for normal symmetric distributions. For data with a symmetric, bell-shaped distribution, the standard deviation has the following characteristics. The total area under the curve is equal to 1, or 100%. About 68% of our data falls within one standard deviation above and below our mean. About 95% of our data falls within 2 standard deviations above and below our mean. 99.7% of our data falls within 3 standard deviations above and below our mean. This shows just how valuable our standard deviation is. It will come into use when we are doing real-world problems that involve percents of our data. These 3 main percents of the empirical rule allow us to find the percent or amount of data in 1, 2, or 3 standard deviations in those areas underneath the curve. They also allow us to find the area or percent of data in the smaller sections underneath the curve instead of our bigger sections. We can use subtraction, division to find the area or percent in the smaller sections. This is what I mean. We know that within 1 standard deviation above and below our mean, there is 68% of our data located there. But if we only needed the range from our mean to 1 standard deviation above our mean, we could take that 68% and divide it in 2 and see that that specific region under the curve has a percent of 34%. Similarly, if I only need the range from my mean to 2 standard deviations below the mean, I can take that 95% and cut it in half and see that that area is 47.5% of my data. If the range from 1 standard deviation above the mean to the mean is 34%, then the range from the mean to 1 standard deviation below the mean is also 34%. Now, if we were asked to find the percent from 1 standard deviation below the mean to 2 standard deviations below the mean, that section in red, I can take what I know already and have figured out and find the percent for that section. I would take 47.5% and subtract 34%, telling me that the area in that section or that range is 13.5%. Let's try a real-world example where this comes into play. This problem tells me that 1,000 freshmen at North Carolina State University took a chemistry test. The scores were distributed normally, with a mean of 84 and a standard deviation of 3. Label the mean and the 3 standard deviations from the mean. Now, the key to this problem is that it tells us that the scores were distributed normally. If I was not told that in the problem, I cannot use the empirical rule because it only applies to distributions which are normal or symmetric. Now in the problem, they tell me the mean or the average score on this test was an 84. Since this distribution is considered normal or symmetric, I know that that mean goes in the center of this curve. Now I need to fill in the standard deviations. I know that each line is 1 standard deviation above or 1 standard deviation below the mean. So I will label those 2 first. So to get 1 standard deviation above 84, I take 84 and I add the standard deviation S to it, which gives me 87. To get the 1 standard deviation below the mean of 84, I simply subtract 3, which gives me 81. To get 2 standard deviations above the mean, I can either start at 84 and add 3 twice, but I already have it added to it once, which gives me 87, so I can just add 3 to that, which would give me 90. Similarly, I can do this for 2 standard deviations below the mean. So instead of taking 84 and subtracting 3 twice, I can start with 81 and just subtract 3 one more time. And I can continue this process for the 3rd standard deviation above the mean and below the mean. So I just add 3 to 90 and also subtract 3 from 78. Now that I have my distribution properly labeled, I can go ahead and start working on the problem. they ask what percentage of scores are between 81 and 87. So first, I want to locate those scores on my distribution. Now that I have found the two scores, I can examine their position in relation to the mean. Looking at 81, I can see that it is one standard deviation below my mean of 84, and I can see that 87 is one standard deviation above my mean of 84. Using my empirical rule, I know that 68% of my data is between one standard deviation below my mean and one standard deviation above my mean. Knowing this, I can confidently say that the percent of scores between 81 and 87 is 68%. Starting with the same situation, they now want to know what percentage of scores are between the scores 78 and 93. So just like last time, I have to locate them on my distribution first. Now that I have located them, I want to look at how many standard deviations above or below the mean those two values are. I can see that 78 is 2 standard deviations below my mean, and 93 is 3 standard deviations above my mean. Now, there are sometimes multiple ways to do this. I will go through one method right now. Knowing that 78 is 2 standard deviations below my mean, I can use the empirical rule that within 2 standard deviations of my mean above and below, 95% of my data is located there. Now, this is not enough to answer the question because there is another section that we must add to this. 95% covers a section which I have shaded in blue, but we must also add the section which is shaded in green. Now, to add this section, we need to figure out what percent that individual section represents. Our empirical rule tells us that within 3 standard deviations above and below my mean, there is 99.7% of my data located there. The way that I'm going to start to solve this problem is I'm going to start with the larger percent, the 99.7. I know that my percent is going to be smaller than 99.7 because 99.7% also includes the section which I am shading in red. That section is not included in the range that they have given us, so we have to remove that section. In order to remove the section, I first must figure out what percent that section represents. What I am now going to do is I'm going to remove 95% of the data from 99.7 so that I will only be left with the red and the green shaded sections. The blue section will have removed. After removing 95% of the data, I'm now left with 4.7. This includes the red shaded section and the green shaded section. I know these two are equal because they are both 1 standard deviation long. So what I'm going to do is I'm going to take 4.7 and divide it in half so that I will have the percent for each individual section instead of both of the smaller sections. .7 divided by 2 leaves me with 2.35%. That is the percent for the red section by itself and also the green section by itself. Now I'm going to add together only the sections that I need. Since I only have the range, or I'm asked for the range rather, from 78 to 93, I know that from 78 to 90 is 95% of my data. And then from 90 to 93 is 2.35% of my data. So I'm simply going to add those two numbers together to get the percent of data that is between 78 and 93. When I add them together, I get 97.35%. I can conclude that the percent of the scores between the scores of 78 and 93 is 97.35% of the data. The last problem we are going to work through is a little different than the rest. It's not asking for a percent this time, it's asking me for how many chemistry students scored between 78 and 84, rather than a percent. So just like before, the first thing I want to do is I want to locate my data values. After I've located them, I can see that 84 is my mean, and 78 is 2 standard deviations below my mean. The empirical rule states that 95% of my data is within 2 standard deviations below and above my mean. I do not, however, need this entire range. I only need half of it. So to find the percent of data located within 78 and 84, those scores, I'm going to take 95 and I'm simply going to divide it in half. Once I divide it in half, I can see that 47.5% of my data lies between the scores of 78 and 84. This is correct. However, they did not ask me for a percentage. They asked me for how many students. I have to use this percent to give a number of students. In the problem, it states that 1,000 freshmen at North Carolina State University took this chemistry test. So now what I have to do, the final step for this problem, is to find 47.5% of 1,000. This will give me the number of chemistry students who scored in the given range. To find 47.5%, of 1,000 students, I'm simply going to multiply by 0.475. I move the decimal place to the left twice to do my calculations. Once I multiply, I see that 47.5% of the students is 475 students. This is an amount of students and not a percentage. Therefore, I am finished with the problem, and this is the correct solution.